We're going to construct the centroid of a triangle, which is found on page 409. Now, the point of intersection of the medians of a triangle is the centroid. Note, when you find where two medians intersect, you have found the centroid. So it's not necessary to find that third median. We're going to construct medians, and a median is a line segment or line that connects the midpoint of a side of your triangle with the opposite vertex. So the first thing we have to do is we have to find the midpoint. So I want to find the midpoint. I'm going to begin with line segment XY. And I'm going to put my point at point X, my compass point at X. And I'm going to cut arcs above and below my line segment. And we've said this many times before. We know where two lines or two marks intersect, that we get a point. And if we have 2 points, we can connect these 2 points and we can get a line. And so I really don't have to draw the line, although I can draw the line that goes through here. What I'm most interested in is this point right here. Because this point, which would be the point of the perpendicular bisector, is the midpoint of line segment XY. That's the midpoint. I'm going to call this midpoint, I'm going to call this line M sub 1. And that's the point on line M sub 1. Now, that's going to give me a median when I connect this point to the opposite vertex, which is point Z. So when I draw Z to line M1, I am getting a median. This goes from the vertex to the midpoint of the opposite side. I'm going to call this point A. Doesn't really matter what you call it. I'll call it point A. Now I want to do this to another side. So I want to get the midpoint for YZ. So if I come along here, and again, if I cut arcs above and below, cut an arc above and below YZ, and I do the same thing from point Y. You're going to be getting pretty good at this now because we do it a lot. Again, we know these two arcs intersect to give me a point. And if I connect this point and this point, then I'm going to get a line. I'm just going to call this line M2. And I'm not really too concerned about the line again, line M2. I'm concerned about the point on this line, which ends up being, this line segment would have been the perpendicular bisector, but all I really want is this point right here because this is the midpoint. So I'm going to call this point B. B is the midpoint of line segment YZ, and if I connect B with point X, which is the vertex opposite this side, that will give me a median. So now I have median XB and median AZ, and they intersect at this point that I'm going to call M. And M is the centroid of the triangle. Now, we could go ahead and do another median from Y through M, and I suspect you'll be able to see, even if I don't measure with my compass, that this point right here would actually be the midpoint of XZ. And all three of these medians intersect at point M. Now there's a very important fact that you need to know about the centroid. When you have a centroid, the length of the segment from the centroid to the vertex is 2/3 of the entire length of the segment. So I want you to put that note in your paper, on your paper. Hopefully you can see this. Note the length of the segment of a median. So the median's got two segments when you put that point in there. From the vertex to the centroid is 2/3 the length of the median. Now my writing is a little messy reaching out this far distance, but what I've told you is the length of the segment of a median. Like, let's just say, for instance, the length of my segment from X to M, which it appears, let's use the metric measurements. From M to X, it is almost 6 centimeters. So if this is 2/3 of this line segment, then from B to M should be about 2 centimeters. Let's measure and see. Did I mess up? No, I didn't mess up. I told you wrong, didn't I? This is 3, and the entire length is 9. So 6 is 2/3 of 9. 3 and 6. Let's try another one. Let's see how long is the segment from Z to X. Well, let's do the whole segment first of all. From Z to the midpoint, it appears to be 1, 2, 3, 4, 5, 6.5 centimeters. 6.5 centimeters. 2/3 of that would be 4 and 2/3 of a half, and 2/3 of a half is going to put it between 3 and 4 centimeters. So let's just see. We've got 1, 2, 3, 4, and between 3 and 4 centimeters. You also could measure with your English measurements. That might be a little easier for you to see this one. For instance, from X to Z is 1, 2.5 inches. 1 and not quite 2, but let's see, 1 and this would be a half. This would be 5/8. That looks like that's close to 5/8. And this looks like it would be 1, it's not even an inch, is it? 1, 2, 3, 4, 5, 6. That looks like 7/8. It's not really exact because it's in there. But because of the construction, we know that this distance, the distance from M to X, is 2/3 of the entire line segment. So if we were using some algebra measurements, I could call this 1/3 of X, and this would be 2/3 of X. Now we don't know what X is. X could be inches. In this case, X would be 3.5 inches. 1/3 of 3.5 inches, 2/3 of 3.5 inches. Or it could be centimeters. In this case, my X measurement would be 9 centimeters. So 1/3 of 9 centimeters, 2/3 of 9 centimeters, which is what we saw to begin with, 3 centimeters and 6 centimeters. So that's a very important fact for you, that the length of the segments of a median from the vertex to the centroid is 2/3 the length of the median.